So one way is looking at a rate or a derivative being inside the integral and having this outside be the original, like the amount of something. The other way of looking at FTC is how our Brever card goes, which says capital F of B minus capital F of A equals the other way of looking at FTC, I should probably use FT, is to look at these guys as being the antiderivative of that guy. Okay. That's the majority of what we're going to use in all of your questions today. Those things on the board. If you guys can figure out the things on the board, you will know how to do every single one of these problems. Okay? So here we go. Packets open, phones put away. I really don't want to start commenting, so I like to trust you guys more than others and trust that you peek at your phone real fast if you really need to. Treat it more like a college class. So show me that you were worthy of that respect. Okay. Here we go. You guys didn't even have any questions seemingly on the non-calculator part? It's mostly just theorems, right? For the calculator part is where we start to get a little rough, but first before that, FRQ number 1, non-calculator. Kiddos, if I were you and you are a highlighting person, remember having a colored pen out and a highlighter out? I would highlight this FRQ. Because this FRQ, the idea where you are given a function that equals an integral from a to x or a to u of another function, let's focus on it. Let's focus on it. If you're bored, remember you should be starting on a new packet. Homework tonight, let's play around with it. If you're not bored, you should be tuned in. Okay? Highlight this FRQ. It's a very, 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 very common one. Kiddos, they say g of 0, g of 1, g of 5. Aren't those x's?
Yes.
So are we going to plug into the x's of, we start at 0, of our integral, and we're going to have the integral from 1 to 0. I'm just plugging into the formula over here of f of t dt. Who is f? The graph. You can say f of x if you want. You can say f of t, either way. How do we do or visualize an integral on a graph? We wrote it down yesterday. Area. So area between 0 to 1, but it's area between the curve and the x-axis. So the curve is down below, the x-axis is up above, so that's the area I'm trying to find. Now, guys, geometry, what shape is that? Please help.
Rectangle.
A rectangle, and a rectangle has what as its area?
Base times height.
So all you need to do is think about a equals base times height for the first one, and plug in what is the base of that rectangle? 1. What is the height of that rectangle?
2.
2, but why am I going to put a negative in there? It's below, so I'm going to have the height be a negative 2. So g of 0 equals negative 2. Done, done, done. Except, what did I not consider? The bounds. The bounds are all messy. Since the bounds are all messy, question, kiddos, do I want to write from 0 to 1?
No.
No, I want it to go, if I'm solving by hand, I want it to go from? Instead of 1 to 0, I want to go from 0 to 1, but if I put the bounds, what do I have to do? So I needed a negative all along. So even though the area is below, you're right, it's below the curve, right? Look up there. Even though the area is below these bounds, 1 to 0 is backwards. So I have to flip it and be 0 to 1, but I need to put in a negative in the process. So then my answer would be a positive 2. Now, the second one I thought was the easiest one out of all of them, because if I'm going to do g of 1, I plug into the x. Kiddos, think about if you saw any of the calculus sweatshirts last year.
It's
1 to 1.
Card. 0.
0. A to A. Last year it was their joke on the back of the sweatshirt. A to 8 hours of sleep. 1 to 1. 0.
How come for the first one I did f of b minus f of a didn't work?
Well, how'd you do f of b minus f of a?
With like
Is f his own antiderivative? then you can't solve for the antiderivative if you don't make a function.
Oh.
So if you really wanted to, I suppose you could have done that if you took all the time to write f of x as a piecewise function and say from like 0 to 2, he's the horizontal line y equals -2, and from 2 to 3, he's the diagonal line of up to over 1 with a y-intercept down to over 1, down to over 1. 2x minus 7. And then you could have made the piecewise function, that would be the top of the square root from 3 to 5. There'd probably be closed brackets here somewhere or others. Would be the square root of, you would have added 0, x minus 4 quantity squared. I mean, if you make a piecewise function, I suppose you could try to anti-derive and then plug in. But the point is, Brandon, an integral of a function is an area under. You know nothing about f without making that nasty piecewise function to find his antiderivative. Does that make sense?
Yeah.
And then g of 5. You guys understand, be working on tonight's homework. If you asked these questions earlier, be working on tonight's homework. Otherwise, you're focused. Then from 1 to 5 of f of t dt. What area is that? I'll use a different color. This one. Start at 1. Where's 1? Here. I need this area, right? Question, do I need to switch the bounds if I have from 1 to 5 just by definition? No, it's fine. It's perfect. It's moving in the right direction. So all I need to do is figure out my areas, and my areas, because I'm not going to go through all the geometry in the sense of writing all the formulas, but help me out. What's the area of this rectangle? Base times height. So 1 times 2 is 2, but it's below the curve. True? So I'm going to mark it with a -2. The area of this triangle, 1/2 base times height. 1 times 2, base of 1, height of 2. And after that, that's going to be -1. 1/2 base times height. 1/2, 1 times 2. It's going to be 1, but it's below, so negative. And this one's going to be 1/2, because it's a half circle. 1/2 pi, and what's my r? 1. My diameter is 2. My r is 1. So then I end up with this guy of just saying -2 plus -1 plus 1/2 pi 1 squared. Kiddos, I'm going to make a huge point right now. Box this answer. Tell yourself, do not simplify. Box this answer and tell yourself, do not simplify. You do not need to, and time and time and time and time again, I see kids simplify. Letter A is all about area. Letter B, it's all about, well, how do I find an absolute extremity? Am I just taking a forever card right now? What am I trying to do? So you go ahead and find the endpoints and plug into the original. The endpoints are going to be 0 and 5, but who am I missing? Critical numbers. How do I find critical numbers of G?
Where the zeros are.
You said G prime of x equal to 0. Who is G prime? How do I take the derivative? Now some of you need to actually do this, write it down for your brain to attach to a forever card. To find G prime, I need to go ahead and take the derivative of both sides. So I need to take the derivative of who G equals, which is the integral from ASB chapel. Is it 1 to x, kiddos?
Is that here?
How do I take the derivative of an integral?
It becomes the function.
Second FTC.
Yeah, I plug in the x. Remember, if you guys need to, you can go ahead and say u equals x. We can just generalize it and assume it's going to be a harder one. And the derivative formula says I need f of u times u prime. That's FTC part 2. So f of u, so I plug in the x times x prime is just 1. and I'm setting that equal to 0. Who is F? The graph. Isn't he the graph? Y equals F? So if I want when F is 0, kiddos, go say, hey, when is F 0? 0 of the Y value is the x-intercept. So F is going to be 0 at the x value 3. Good job. So I can go ahead and come back and I can plug in. This is going to be true at x equals 3. Does 3 fit in between 0 and 5? The answer is yes. I put in 3. Oh no, I plug all this stuff into my G? Hold on, didn't we already find G of 0 in part A? Where's G of 0? Did we already find G of 5 in part A? Now, this one's a little bit nasty because you're like, oh, stink-a-dink. Oh my goodness, well, okay, negative 2 plus 1 is negative 3. Plus 1 half pi. Now it's a good time to think about. Now's a good time to think about the approximate. This is going to be approximately, let's see, 1 half a pi. Pi is approximately 3 if you want to go that route. 1.5-ish minus 3 is negative 1.5-ish. What do I do with 3 though? I don't know that one. Go find that one. And so to go find that one, we're going to take him just for a second. We're going to do exactly what we did in part A. We're going to plug in G of 3 is equal to, using the definition above, 1 to 3 of f of t dt. I need to figure out the area from 1 to 3. Guys, are my bounds okay? Yeah, my bounds are okay. It's from lower to higher. From 1 to 3 in my graph, negative 3.
If you have the areas there.
The critical number is positive 3, right?
Yeah.
Okay, so then my bounds are from 1 to 3, right?
Yeah.
So I'm going to my graph, right?
Yeah.
Oh, you're telling me the answer.
Yeah.
I was going to show people on the graph real quick. There's my 1. I get it. I thought you guys meant 3 should be negative 3. I got super confused. That's the area I'm trying to find. We already figured out negative 2 and negative 1, so yes, the area is going to be negative 3. So I can go ahead and go plug that in. Negative 3. Looking at my table, kiddos. Who's the highest? Who's the lowest?
The minimum is negative 3, the max is.
Yes, the lowest happens at 3 and the value is negative 3, and the highest happens at 0 and the value is 2. So I'm going to say my absolute max value. Do we plug in the y or plug in the x? Did they say values? I see that, just hang in there. Oh, come on, we talked about this yesterday over and over again. Value of, is that the y or the x?
The
Y.
That's the y value. So I'm going to plug in absolute max of 2. And then I'm going to go ahead and do absolute min of what? The highest it goes is 2, and the lowest it goes is negative 3. Katrina, go.
I have a question on, it's the separate cube, but it was like a different one. If you could explain real quick.
Say it one more time.
I have a question on the separate cube, but it's like a different one.
A different part?
Yeah.
Okay, I'm going to explain it real fast though. Go ahead.
Yeah. Why is, for B, G double prime of 2D?
Oh, because G double prime, we just talked about how G prime is equal to F, right?
Yeah.
And then from that, we could go ahead and go another leap and say G double prime is equal to F prime.
Yeah.
And since we have the graph of F, that looks like F double prime now. Since we have the graph of F prime are slopes, right?
Mm-hmm.
So we can say the slopes of the graph are the slopes of F. So what we're asking G double prime of 2, we're trying to go to 2 on the graph and say, what is the single agreeing from both sides slope at 2?
Oh, it's 0.
Isn't the slope 0 before and positive after?
Yeah.
Since the slopes do not agree, the derivative does not exist, which we should also know because isn't this something called a sharp point?
Yeah.
Since we have a sharp point, the derivative has to not exist. Does that make sense? So therefore, G prime of 2 does not exist since F of 2 is. Now, I think they did something where they explained it how the one-sided limits of the slopes don't agree. But you could have also just said sharp point.
Okay.
Oh, okay. Sorry. That would be just the justification. Alright, then you guys had questions on these ones. Kiddos, some of you are missing FTC part 2. A, study your forevers, and B, write it out for your brain. So I'm going to do this fast. To find g prime of 2, we take the derivative of g, and to take the derivative of g, we have to take the derivative of who g equals. It is what it is. Some of your brains need to write this out. You can't just visualize d dx. It doesn't do enough to get you to the forever part. You have to write out d dx. But hopefully as soon as you write out d dx, you're like, oh hey, FTC part 2. FTC part 2. And FTC part 2 says, take this little guy is a u. F of u times u prime when you're taking a derivative. F of u times u prime. F being whoever's on the inside. So I'm going to go ahead and plug and check. So I'm going to have sine squared of who? Of x. X gets plugged in. Times x prime is 1. Where am I trying to find this at? 2. So all I have to do is plug in x equals 2 into my calculator. Dun, 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 dun. Number 3. They tell me the integral, which means area, from 2 to 4. They tell me the integral, which is area, from 2 to 4 is equal to 7.5. They tell me that f is an antiderivative. So kiddos, isn't this antiderivative of b minus antiderivative of a? Wait, isn't that just FTC? What does antiderivative of b minus antiderivative of a equal? Oh, so they're just giving me a super snazzy way of saying find the integral from 0 to 4 of f of x dx. Oh, well that's funny. They already gave me 7.5. They already gave me half of it. What are they asking me to do? Find the rest of it and add it together. That's shaped as a trapezoid, but if you don't like trapezoids the same way I don't like them, I honestly don't. I just think of it as a triangle plus a rectangle. So I can go ahead and say that triangle has a base of 2 and a height of 1. 1 half 2 times 1 is just going to be a positive 1. This rectangle has a base of 2 and a height of 2. Isn't it going to be an area of 4? So it's 1 plus 4 plus 7.5. Nope. Dun, dun, dun. Okay. That was just a snazzy way of using FTC to have you keep on finding area. Number 5. Some of your brains need this. To find h double prime. Start with h. Uh-oh, I need to take one derivative of h. Struggle. H prime. Some of your brains need this, right? d dx of the integral from 1 to x of g of t to t. Isn't that FTC part 2? U equals x. Plug in u. G of x times 1. AKA just g of x. Oh, plug in 2.5. No. What do I need? H double prime. So how do I take H double prime? We'll go again. H double prime of x. I got down to this nice g of x. I need the d dx of g of x. Wait, who's g of x? What did they tell me about? So I need, some of your brains need this, d dx, the integral from 0 to t squared of this nasty, ugly function, 1 plus u squared all over u du. But guys, FTC part 2 again. Who's my u in this integral? To solve, I'm going to go ahead and find what's f of u times u prime. It's time to plug this puppy in. Needs to plug in wherever there's an argument. Needs to plug in wherever there's an argument, and then times u prime. So I'm going to end up with the square root of 1 plus who squared?
T squared.
T squared squared. All over who? Times who prime? T squared prime. What do we have to do to finish this problem? Plug it in. Plug it in. Where? Every time you see a T. this is a calculator problem. Plug and chug, you have your answer. Plug and chug, you have your answer. This gets us to our FRQ that you guys got stuck on. Some people were debating whether this was an even or an odd. I saw number 8 as the problem before, so this would be problem 9. I saw it also as FRQ number 1 of the second portion. However, some of you are like, what is the second FRQ? Couldn't it be even? Alright, fine. I'll count it as bonus, so I'm not going to solve the entire thing. But I will just peek at a few. When you see equation of tangent line, what do you think? Exactly. That's perfect. Y minus y1 equals m x minus x1. Now I'm going to go ahead and erase some stuff, but I'm hopefully plugging things in, right? M is going to be the derivative of who? G. At 3. So I can plug in x1 is 3. I can plug in 3 to my g prime. Oh, I need my y1. No problem. So I just plug in 3 to g. Same way I plug it into f, I plug it into g. Now it's a little bit messy, but kiddos, this is a calculator problem. So couldn't I technically find g of 3 using my calculator? Because g of 3, go plug it in. It's going to be the integral from 0 to 3 of, nope, not 0 to 3. Rookie mistake, 1 to 3. Of 5 minus 8 square root. Should you do anything by hand in solving this integral? No. Use that calculator. It'll do it for you and get a decimal. Use that calculator. That's going to be g of 3. How do I find g prime of 3? Take the derivative of g. And taking the derivative of g, write it out. d dx of that guy, d dx of that guy. Isn't that derivative of an integral? So isn't that just going to be 5 minus 8 square root of ln of 3? And make things a little nicer, I'm just going to go ahead and say y minus the integral from 1 to 3. 5 minus 8 square root of ln of t dt equals 5 minus 8 ln of 3. Oh, I forgot my square root term. X minus. Plug and chug that puppy to your calculator. Okay, kiddos, hold on. Some of you are taking stick it to the man and having way too much fun with it. What do I mean by that? Can you box this and say, no. The only thing you're allowed to box is expressions with numbers, no calculus, that haven't been simplified. You could box with that. You can't box with him, because what do you still need to do? Take the integral. Take the integral. Take the integral. You still have to take the integral. But all you gotta do is use your calculator for that. There is no by hand work that needs to be done. You already did it. Plug it in. What is h prime? H prime of x is going to equal ln of u times u. You do dx of both sides. There's my u, f of u times u prime. Plug it in the integral. On which intervals is g decreasing? We've already talked about who g prime is. Figure out where g prime is less than 0. You can use your graphing calculator to graph them. You can figure them out. Relative extrema of h. We need to find critical numbers of h. Take h prime, set it equal to 0. Then technically we have options. We can either test signs before and after. Signs of who? H prime. That's the first derivative test for relative extrema. Or we can can take those critical numbers and plug into h double prime of x and check concavity with the signs of the second derivative. We have options. Kiddos, I'm not doing more because this is the even. I already called it the bonus. If you are able to finish it right now, cool. If not, no big deal. Show me the even later. Let's go ahead and get these passed up. We went over all of the odd questions, evens. I gave you enough clues to get you going. We have about 6 minutes to get going on our next packet, which the nice thing is, guys, these, if you notice, they really fit together. Like you're going to see fundamental theorem maybe on an earlier packet, but then we really dig in on this packet. You've seen areas, which is what this next one is going to be, areas and Riemann sums. Oh, make sure name's on it. Sorry, I forgot to write the name blank on these ones. Some people have been getting confused or irritated. Alright, as soon as you pass it up, open up the packet. Okay, so open up the packet. On the notes online, kiddos, I'm not saying a lot of you guys have extra time. I'm not saying that. What I am saying is some of you know that some of these topics you're weaker on than others. That's what I'm saying. Or you're like, okay, we've gone over questions, and Steve's given me a lot of hints or clues, reminding me of forever cards, trying to help me work out some things. But you're like, great, I have no more problems to try because I just used them all up. When I have these answer keys in your class notes, and this is what's being saved every day. Laying the Foundation Review is saved in your class notes folder. I'm just updating it every day. At the end, where there are the answer keys, they have this little section where they say, hey, here's some free response questions that included these topics. What free response questions? Oh, the official ones that were given that year, that there's that website. If you just search CalcAB free response, it's on my links, but most of you guys are like, oh. You can go find the whole collection of FRQs and go find that year and go find that question. You can check it out and try that. So if some of these areas are your weaker areas, this tells you where you can go look and find some other AP questions that include it. You can test yourself on it. Just want to let you know real quick. Alright. Approximating definite intervals, Riemann and trapezoid sums. What's a Riemann sum? Rectangles. Riemann sums. Right here. Right, left, midpoint. This example has been totally solved for you. What I'm reminding you of really quickly is for Riemann sums, we're using area equals base times height, where base is some sort of delta x, change in the independent variable, times some sort of f of x, and I'm going to say f of x sub c or sub star. That little sub c could be f of x sub l for all the ones on the left for each little baby subinterval. It could be f of x sub r for each of the y values on the right of the subinterval. F of x sub n for each of the y values in the middle, depending on which one you're trying to find. But guys, they gave you a great example of, hey, here's a graph with a table. Here's a graph with a table. How would we do Riemann sums? And in these ones, they were all equally spaced, which is not always the case, but in these ones they are. They give more notes for how to think about right and left and midpoint, but they also give us some more examples. Can we go ahead and just go to this example real quick? It's on the second page. I want you guys to go to this example, and if I were you, I would highlight this one because this is what the AP loves to test on. Whenever a Riemann sum appears. They give you a table, and if you guys notice in this table, are these jumps equally spaced?
No.
No. These jumps are not equally spaced, but does that mean we still can't make them? No, we can make those jumps. So if we were to do a left, this one's impossible to do a midpoint because they didn't give us enough points. They have to give us enough to jump over for midpoints, that way we can find a y value in the middle. But for the left, using 3 subdivisions. That 3 subdivisions tells us how many jumpity jump jumps. We're going to use a base of the delta x, which is why you see the 8 down below. These are my bases. But for the height, why am I circling, why am I highlighting 34 for left?
Because you're starting from the very end.
For this subinterval from 0 to 8, we're choosing the height or the y value on the left, which is 34. We're using the height or the y value on the left. So as I form a new subinterval for this next one, what's the base on the next one, guys?
3.
Yeah, the base is 3, which is what you can see down below. The base is 3. What's the height I'm going to use for that one?
65.
65, because on the left of that subinterval is 65. The left of that one was 34. And as I go to the last subinterval, what's the base as I make that jump? 6, which is why I see the 6 down below as the base. And what is the height I'm going to use for that one?
40 or
67, because I'm using the ones on the left. So you can see the bases times the heights. The bases are found by the delta x's. If you want, you can actually write those little bases in. I have 8, and then I have 3, and then I have 6. As seen down below. The heights, I'm using all 3 on the left. What changes when I come down here for the right? Are my bases any different? No. All that's different is, what am I using instead for my little subintervals?
The right.
I'm using the ones on the right. The ones on the right, the ones on the right. So I'm just using 65, 67, and 43 instead. That's the big idea of how to do Riemann sums. There is something down below having to do with the relative approximations. We're not going to talk about those until tomorrow. I'm going to make actually forever card number 50 having to do with how to know whether it's an over or an under approximate. Kiddos, once again, I am going to save period 6's notes because we had computer troubles, so they might have skipped some examples. But you might have got the notes online for period 6. I'll take your guys' video, but I might go ahead and get a little bit further. Bye, kiddos.
No, I don't believe in all.
You're like me,
I
really.
don't believe in pain either. Just the expression for it.
I told her we're
Yes, you didn't know.
Because like a Russian
She goes, which one is it? I was like, the first one.
typical Russian movie. He's like 6. He's like, I don't believe it. Too expensive. Yeah, that's from Ocean's 11.